you'll have to use the microphone on the laptop.
Okay.
Okay, everyone. Okay, so we're going to get started on the second keynote. So probably also somebody that doesn't really need an introduction, but we have Miles Lubin here. Miles is one of the creators of JuMP. He's now at Google, and he's going to be telling us how we get to JuMP 1.0.
Thanks everyone for coming. So just to start off, I do work at Google, but JuMP is not a Google project. They have a generous policy for employees contributing to open source, so that is the extent of the relationship between JuMP and Google. No.
No.
I can try speaking louder. Okay. Okay, so the last two JuMP-devs, I think last year I spoke for almost 2 hours. This one will be a much shorter talk, about half an hour. I'll be covering a bit of introduction to JuMP, how we got to where we are now, the 0.19 release, which was our came out very recently, and then the roadmap for JuMP 1.0. Okay, so just to give a bit of context, who is it behind JuMP? If you look at the list of contributors to the GitHub repository that tells some of the story, not the whole story, we have myself, Ian, Joey. We're essentially the founding developers, started in 2012. Since then, we've had 2 new entries into the top 5 contributors, Benoit and Oscar. I would call them JuMP the next generation. That's just part of the story. We had a really large number of contributors to the 0.19 release. So I'll avoid thanking people twice, but I think everyone's name appears at least once here. Joachim also had a big contribution to MOI. So JuMP is split across a few packages. Just looking at the JuMP contributors doesn't tell the whole story. We had a large number of contributors before 0.19. And while I'm thanking people, also thank the local committee for JuMP-dev. Thank you. And that's a bit of the picture behind who's behind this project. So what is JuMP? One of the answers I would give to that is I say, well, JuMP is a modeling language for mathematical optimization, just like AIMS, AMPL, Simple, Cplex, Concert, CVX, CVX, GAMS, GNU MathProg, Groby C++, Python API, Lingo, MATLAB, problem-based workflow, MOSEC, Fusion, Mosel, MPL, Ampere, OptModel, Pulp, Pymo, YALMIP, and Simple. Does did I miss something? I think those are the major ones. So you can ask, why is JuMP in particular interesting when there's so many other modeling systems that do pretty similar things? So I would say it's interesting because JuMP is open source. A number of the modeling interfaces that I listed are commercial, and they're tied to commercial tools. JuMP is embedded in Julia, so if you're a fan of Julia, JuMP is a very natural choice. We have low overhead for model generation. Once you move into, so I've heard stories for people switching to JuMP because they were using other tools that where the time to generate the model and do all sorts of processing took longer than solving the problem itself, and that's not a situation that you want to be in. JuMP solver independent. Usually you can plug in your favorite solver, switch it, try out different tools. That's nice to be able to do. You can connect to new solvers. You can connect new solvers to JuMP relatively easily. You can extend JuMP to new problem classes. JuMP supports interacting with solvers while they're running. This is a rare feature in modeling interfaces. We're going through a bit of turbulence in this API right now in callbacks, but JuMP has a pretty solid story, and Julia gives us the hooks to interact with like a branch and bound solver while it's in the middle of solving the problem. That lets you do very powerful things. These were all technical points, and on top of that, we have, I'd say, a pretty active community. The fact that we're having this workshop and that we can convince a number of people to fly to Chile just to talk about JuMP is really impressive to me at least. Okay, so this is kind of just a demo. We had the tutorial this morning. This is kind of just a proof that JuMP is a modeling language. You can write down, create some variables, create some data, create some variables, add some constraints, say solve, get a solution back. So I won't step through this. It's just a demo of how JuMP works. Okay, so building up to 0.19, JuMP goes back to 2012. We had a big history of substantial changes to JuMP even before 0.19. So we added callbacks in December 2013. We added nonlinear optimization. We added semi-definite optimization. We rewrote nonlinear optimization. We renamed everything from camel case. The sum with the curly braces became sum with the parentheses. So if you've been using JuMP for a while, these will be familiar. If you have not been using JuMP, you may see some old code out there that uses camel case or curly braces. That won't work anymore, but just so you know, that was the right way to do things. So while we were incrementally adding all these new features to JuMP, building on top of it, we started collecting a list of feedback, list of questions that we did not have good answers to. So I'll frame this as JuMP is great, but how do I do X? And that X could be, how do I add support for a new type of constraint? So someone comes along and say, why doesn't JuMP support complementarity constraints? How can I make that happen? Until JuMP 0.19, we didn't have a good answer to that. How do I combine NLP constraints with conic constraints? This is interesting because we now have new solvers out there that can handle this combination. How do I delete a constraint or variable? Going back to the beginning of JuMP, we made a decision that who needs to delete a variable? You can just make a new model if you want to delete something. It turns out that people like deleting variables, but that was a very fundamental assumption that took some restructuring to address. How do I know if my changes are passed efficiently to a solver? So JuMP tries to be efficient and pass, avoid reconstructing the model when necessary, but we would not always provide feedback on when that's happening. How do I modify coefficients in the constraint matrix? How do I provide a dual warm start? How do I access the irreducible inconsistent subsystem from Groby? How do I distinguish between a solver that stopped because of the time limit with a solution and without a solution? How do I check if a solution is feasible? How do I access multiple solutions found by a solver? This is just a selection of questions. But these are kind of the list of questions that we accumulated up to JuMP 0.18, and we didn't have easy answers for them because they the way we built up our infrastructure did not provide us with an easy way to answer these questions. So it did take a few meetings, a few JuMP devs to figure out what to do. We laid the groundwork about 2 years ago, came up with a framework for MathOpt interface. Last year, we had most of the pieces in place for the release. And then about 3 weeks ago, we finally released JuMP 19. And this is probably, I'd say, the biggest release in JuMP in quite a few years. I'd say, I'm surprised that more people didn't like it. You should go and like Juan Pablo's tweet now. Okay, so what is it that actually happened in this release? What we did is we replaced our abstraction layer, MathProg base, with a new package called MathOpt interface. So MathOpt interface is the way that JuMP communicates with solvers. So we have let's say 20 different solvers that JuMP could communicate with. MathOpt interface provides the abstraction layer that JuMP uses to communicate with solvers. That you can imagine that this piece of it was the most substantial change because it required basically taking out the engine of JuMP, replacing it, and having everything run smoothly afterwards. We had all of the solver wrappers needed to be rewritten because they now had a new way to interact with JuMP. That was a pretty substantial project. So that's the most substantial part of the release. We introduced bridges, which are automatic constraint transformations. We redesigned the JuMP containers, dense access arrays, sparse access arrays. We redesigned defined expressions and quadratic expression data structures. We rewrote the documentation using docstrings and documenter. We improved code quality and testing. So for example, we now have a JuMP style guide that gives some guidelines on how code should be formatted, standardize things to make it easier for people to contribute new code, and you don't have to argue about should I put white space here or should I have this parentheses here? How should I break new lines? Just having a standard way of doing these basic things makes it easier to maintain the code. So for more detail, I would point you to my talk on last year's JuMP-dev to go through all these technical details. And we'll also have Benoit's tutorial tomorrow afternoon that will cover a lot of these points. Okay, so kind of to give you a bit more detail on point 19, I looked at the difference in lines of code from point 18 to point 19. In JuMP itself alone, we added 11,000 lines of code. We deleted 10,000 lines of code. We changed 2,800 lines of code, and only 1,500 lines of code were not touched. So basically, it all changed. In MathOpt interface, which is a separate repository, this is a whole new thing. We added 15,000 lines of code. That's a bit. That's a large number. It turns out half of that is for testing. So it's not 15,000 lines of code of logic. 50% of it is testing and writing out optimization models that solvers should test against. So half of that is testing. We're also solving a lot of pretty tricky questions, like those list of questions that I pointed out. It does take a few lines of code to come up with a good way to address those in a clean way. So this is a very substantial project. We had 13 major contributors who we thanked on the release announcement. One thing that we should all be proud of is, I'd say, 0 major bugs since the release. It went a lot more smoothly than than one could have worried about. We were relatively cautious and let's put out a beta release, let's put out a release candidate, let's get feedback. And I think that worked out well because we had no angry emails, no trains crashing, no airplanes crashing. It's been a pretty quiet release as far as I've heard, and a few people I've talked to who upgraded, I've asked them like I'm worried that they spent like a week upgrading and they, no, I just changed a few things, it's fine. And that I'd say that's a success on our part. So for users of JuMP, it turned out to be not very breaking changes. We have a few aesthetic changes in how you get statuses from the solvers. Anything JuMP and below, and especially dealing with solvers, that changed entirely. So that's where most of the work went. But if you're just a user of JuMP, my perception is that this has been a relatively smooth release. And to give a sense of how many people are using it, in terms of, we can measure who looked at the documentation. We have about 10,000 page views from 1,500 unique users over the past 3 weeks. So that gives you a scope, an estimate of how many people have been upgrading and maybe how many people are using JuMP or are least in the first 3 weeks. Stefan, do you have figures on how many people read the Julia docs?
Not off the top of my head, no. For all might know, but
yeah, it'd be interesting to compare. But okay, so that's the 0.19 release. For JuMP 1.0, I'm going to present a roadmap. First question you should ask is, what does 1.0 mean? Kind of implicitly, it means that it's stable and ready for use. So this is, even if you're conservative about adopting new software, like I don't want to try new things, let other people try it first. After 1.0, we can say a lot of people have tried JuMP already. Now it's time. Now you don't have to be too worried about it. What we will do is follow semantic versioning for feature breaking changes. So this is consistent with the Julia ecosystem, which basically means that whenever there's a breaking change, you increment the major version number. So after we release JuMP 1.0, the next breaking change will go into JuMP 2.0. That's kind of just the definition of how we use version numbers. Okay, so who decides what's on the roadmap? I would say the core developers by consensus. Who is a core developer? That's a trickier question. If you're into open source governance, politics, and theory, come talk to me because we might need a bit more structure. But for the moment, it's a pretty informal structure, and it's basically driven by consensus of the core team. And okay, so the reason that we are creating this roadmap is to let the community know what our plans are for JuMP 1.0, so that you can make plans around this, and so that you can, if you're interested, find a way to contribute. What we're going to do for 1.0 is create a website for JuMP. JuMP has survived for, I don't know, 7 years without a website. I think it's time. We have JuliaOpt.org, but that's not really the same thing. And we're also going to deprecate JuliaOpt, so I'll go into more details on these points in a bit. We will deliver on a few promises from MOI that we haven't really completed yet in the 0.19 release. Address a few regressions, address the major regressions from 0.18. So in order to actually release 0.19, we had to, for example, performance degraded in some cases. We'll address those. Some easy usability issues, documentation, and then MOI 1.0. That gets a bit technical, so I won't go into the details of what will go into MOI 1.0. So after my talk, I'll synthesize this into some markdown and put this on the JuMP documentation. Okay, so for creating a website for JuMP and JuliaOpt, we were lucky to grab a nice new domain name, JuMP.dev. As you know, JuMP is a very common word. So the .dev domain came up a few weeks ago, so we grabbed that very quickly. What we will, so I'll ask is, please tell us what you want to see on it. So this is a community, this is a website for everyone. We'd like to know what's useful information. I don't have the best perspective on what someone who has never used JuMP before would want to see, because I'm not really in that position. We'd like to hear your feedback. We also need some help designing it. So if you're a web designer or have a friend, put them in touch with us, and we can, we have some funding to make that happen. As far as JuliaOpt, JuliaOpt started around the same time as JuMP, maybe 2013. That was at the time when Julia community was a lot smaller than it is now. And the idea behind JuliaOpt is that let's make one GitHub organization for all of optimization in Julia. And that was nice at the time, but Julia's kind of grown beyond that. There are other GitHub organizations that do optimization. There's Julia Smooth Optimizers. There's Julia NL solvers. And if you look at what JuliaOpt now, it's mostly an organization for JuMP. So we're going to kind of change that branding and make an organization and call it what it is. It's the GitHub organization for JuMP for the purpose of managing permissions on the repositories, on the people who need to collaborate on JuMP. Okay, so for promises for MOI, I listed a few things, questions that motivated us into the design of MOI, but we still haven't hooked up all the pieces, and we don't really have an easy solution for this yet. So if you come to JuMP and say, how do I check if a solution is feasible? We don't really have an API to do that. How do I access the IIS from Groby? We don't have a way to do that. So if you don't know what an IIS is, don't worry. If you do know what an IIS is, then you'll be really excited for us to hook this up. How do I access multiple solutions found by a solver? So we have the APIs to do this, but we haven't really connected this all the way. These are a few of the things that we'd like to finish off before we declare a 1.0 release. We made a few regressions on JuMP-18. So for example, we're aware of some performance regressions in model generation. We removed the callback API. We removed the column generation API. There's a couple solvers out there that are still not compatible with MOI. We'd like to clean up all these, again, before we declare JuMP 1.0. We have a discussion on Thursday afternoon that Oscar will be leading on what to do about callbacks. So if you're interested, come talk to us. We have a plan for addressing a lot of the performance issues that require some restructuring in MOI, and we decided we don't need to wait another few months to release 0.19, but we will address these before the 1.0 release. Easy usability issues. So once in a while, people open issues like this macro has bad error messages, passing solver independent options. If you've taken a first class on linear programming, you probably know what an LP sensitivity summary is. This is not available in JuMP, and the reason it's not available in JuMP is because after that first class, you never use it again. So it's not actually, that feature only exists for teaching your first class on linear programming. But we decided let's just throw that in to make JuMP a bit easier to use for the first class on linear programming. Solver independent options are important. These are like relatively, what goes in this category of things that relatively small changes that we've been putting off or we decided not to do, but these are the things that we'd like to tidy up before we call JuMP 1.0. So in this category, this is kind of the biggest area where feedback can make a difference. So if you see like little weird things, something prints out the wrong way, the error message is not nice, all these or features that would be relatively easy to implement, these things we'd like to tidy all of this up before 1.0. So let us know about it, and we'll decide if it falls in this category or not. Oops. In terms of documentation, I would say the JuMP documentation is mostly complete, except we don't document how to set starting values. That's an open issue. But besides minor things, the JuMP documentation is mostly complete, but it's a bit of a jumble. So there's a blog post by Divio that proposes to split documentation into 4 different categories. Tutorials, how-to guides, explaining concepts, and technical reference. And the JuMP documentation is kind of a weird mishmash of how-to, explaining some concepts, and technical reference. We'd like to clean that up a bit and restructuring things. This is a larger project, but I think it's worth the time and worth the investment. Okay, so that's the end of the 1.0 roadmap. If your favorite feature is not there, come talk to us about it. We also have a list of things which I'll call post 1.0. These are things that may or may not happen. These projects may never be implemented. They might be implemented. It's more of a list of things that the core developers are interested in. So if you're also interested, come talk to us. We may be able to mentor the projects, but not do them ourselves. So these would be unit testing for optimization models, making nonlinear programming a first class in JuMP and MOI, rewriting and cleaning up JuMP's macros, better support for variable transformations, special math for mutable numbers, constraint programming, discipline convex programming. This is, I'd say, a list of things that what gets something onto this list is that at least one core developer has some interest in it, but maybe not enough to devote their full time to it. But if anything here sounds interesting, come talk to us. Yes?
What do you mean by first class for nonlinear programming?
I mean that expression, there's a barrier between the MOI representation of a nonlinear expression and the internal representation of a nonlinear expression.
Yes.
I would say that that's not first class. So first class would be, for example, having an MOI, something in MOI that represents nonlinear expressions instead of the evaluator interface. So one of the motivations for this roadmap is to kind of direct people, if you're interested, here are the things that the JuMP developers want to work on. If they align with something you're interested with, come talk to us. We have funding available both through Google Summer of Code and NumFocus. If to make a small project for students, we can arrange those. We're always open to code contributions. If you have a idea for a very significant code contribution or anything a bit more than fixing bugs, come talk to us first before spending too much time on it. But I'd say we're pretty responsive in the Gitter channel. If you like to ask us questions, the average response time is, I'd say, pretty good these days. If you're not comfortable contributing code and you're happily using JuMP, you're welcome to just post your code examples. Examples help. People look for them on the internet. Having more examples helps everyone out there. Answer questions on Discourse. That's an easy way to help. Stack Overflow is another one. Now that JuMP is a NumFocus project, if you don't have time, if you like JuMP a lot, you don't have time to contribute code, you don't have time to post your examples, you're welcome to give us money and we'll redirect that to people who do have time. And finally, please give us your feedback. I think one of the major points that JuMP.19 demonstrates is that we take feedback very seriously. We spent almost 2 years rewriting the whole API to make it more usable for everyone that wants to use JuMP. So we do take it seriously, and please let us know if there are issues. And with that, I'll say gracias y que disfruten de JuMP-dev. Thanks, and hope you enjoyed JuMP-dev.
So we have time. Question?
How this will affect the other packages around the I think JuMP is not only the one package that we talk about, but there's also like stroke JuMP and other packages that work around it. How does the pipeline and roadmap for all of those packages? Is there any idea whether also those will be maintained as done with JuMP, or maybe merge into JuMP eventually, or how does it look like for the rest of things around it?
So this roadmap is for JuMP and everything below JuMP. So I'd say JuMP, MOI, and solvers. It doesn't cover extensions, and we don't have plans to merge those into JuMP. We have to talk offline about specific details. Yeah. Yes.
First question is, what are extensions?
Yep.
The second question is JuMP or will it be able to choose a solver based on the structure of the model without the user having to know which I have no, sorry, choose a solver. Yeah, I have no idea which solver to use for a given structure of model. Can it somehow guess that?
Okay, so for the recording, what is an extension? An extension is lets you write a problem in a structure that JuMP doesn't support. So for example, sum of squares lets you write down polynomial constraints in a very specific form. Struct JuMP lets you write down a model that has explicit block structure. So you have variables are grouped into different blocks and they coordinate, and you expose that structure to the solver. So it's I would call them modeling extensions. What will JuMP be able to choose solvers automatically? That would not be too hard to do. We definitely need, this ties actually into the website. We need a better way to direct people what solver should you use given a problem. I'm not convinced that that's a fully technical problem or if it's more of a documentation question. Like if you don't know, you wrote down a model, okay, you can ask, what are the properties of this model? What are the solvers? I'm not entirely comfortable directing people automatically to solvers because then you start to confuse, did JuMP solve the problem? Did the solver solve the problem? Why did JuMP give the wrong answer? We've gotten that a few times. But yeah, that's an area where there's room to develop there. That the automatic choosing solvers is not in the scope of 1.0. The documentation issue and how do you choose a solver, I would say that is in the scope.
We have a
Yes.
configuration link for us upstairs?
Yes.
But-
So on the second floor where we started, this one.
Yes.
Yeah. So yeah, short coffee break and back here at 3.
Yes.